Imagine you're standing by the side of a road. A car zooms past. You have no radar gun, no speedometer access, just a stopwatch and two road markers a known distance apart. Can you figure out how fast it's going? Pause and think about it. Here's the setup. You have two markers on the road, call them A and B, separated by a known distance D. A car travels at roughly constant speed between them. You're standing nearby with a stopwatch. That's all you need. Let's build some intuition. What is speed really? It's just how far something travels divided by how long it takes. If a car covers 100 meters in 5 seconds, it's traveling at 20 meters per second. Simple, but powerful. Now watch the measurement in action. The car approaches marker A. The moment it crosses, start. The stopwatch is running. The car cruises past. And when it reaches marker B, stop. You've just measured the travel time delta T. Now let's write it down formally. Average speed equals total distance divided by total time. We know the distance D between the markers. We measured the time delta T. So the speed is simply D divided by delta T. One equation, that's all you need. Let's plug in real numbers. Say the markers are 200 meters apart and your stopwatch reads 8.0 seconds. Speed equals 200 meters divided by 8 seconds, which gives us 25 meters per second. Multiply by 3.6 and that's 90 kilometers per hour. And there it is. Watch the speedometer climb as the car crosses from A to B. 200 meters in 8 seconds gives 25 meters per second, 90 kilometers per hour. You've just built a speed trap with nothing but a stopwatch and some road markers. V equals D over delta T. That's the whole method. Pick two markers, start the stopwatch at A, stop it at B, divide. This is exactly how police speed traps work. It's how Galileo first studied motion. The simplest physics often gives the most powerful results.